So fine. So let me go to your book, Carbon and its Compound. So yeah, where in Carbon and its Compound you
You
have
have started recording, right?
I can do it and I can send you also as a backup.
Oh, okay then. Okay, then that will be fine.
Fine. So bonding in carbon, the covalent bond and all you have done. You are saying that functional group you have certain out. Okay, let's go to functional groups then.
No, functional groups, I couldn't understand.
Hmm.
So, I need definitions for functional groups.
Sorry, I didn't get you. What?
I didn't understand functional groups.
Hmm.
So, I mean, I understood, but I didn't read them in depth. So, functional groups, if you can provide an explanation.
Okay, sure. And then we'll talk about nomenclature also. That's fine.
Okay.
Okay. So functional groups are nothing but those particular combination of compound or combination of elements or such compound which when it is added to any other compound it changes their complete functionality. It's like if it is methane and if you put an alcoholic functional group into it, it will become methanol, right? So
Yes, yes.
the major property of methane, whatever the property methane carries, that will no longer be valid. It will work as an alcohol then. Though methane properties will be there, but the primary properties will be alcoholic now. Okay, so if I go with that, I'll go with page number 65. Will you be my friend? 4.2.3. So carbon seems to be a very friendly element. So far, we have been looking at compounds containing carbon and hydrogen only, but carbon also forms bond with other elements such as halogens, oxygen, nitrogen, and sulfur. So far we were seeing like before this, whatever hydrocarbons you have studied. So hydrocarbon contains only carbon and hydrogen atoms, and but carbon is again it's a very versatile element, so it will be it actually forms bond with other elements also such as your halogens or oxygen or nitrogen, sulfur, these atoms as well. So in a hydrocarbon chain, hydrocarbon is like where all carbon and hydrogen bonds are only there, like methane, ethane, propane, butane, all this. So one or more hydrogen can be replaced by these elements such that the valency of carbon remains satisfied. In such compounds, the element replacing hydrogen is referred as heteroatom. So what happens is in a okay, let me show you.
So, is my video on or off?
It's off only
Okay.
because your video option itself is not coming, and because of that, uh, I mean the permission option is not coming for me to provide you the permission.
Okay.
Okay. So what I'm trying to tell here is if you have, let's say, C2H6, what is C2H6? It's ethane. So if you have C2H6, the bond or the structure of this will look like this. So now, what if one of the hydrogen, if I remove it with some other element, imagine if this hydrogen I want to remove and I want to put a chlorine here. So what will happen now is I'll remove this hydrogen and I'll put chlorine. The moment you do that, so the hydrogen which you remove is called heteroatom, or which is replaced, you can say it's called heteroatom. And chlorine is one of the functional group of your it will make it chloroethane basically, right? So chlorine comes under halogen, chlorine and bromine, bromide both. So this the new uh, chemical formula what you have got here is nothing but C2H5Cl. So this is nothing but your chloroethane. So this comes under nomenclature, that why we call it chloroethane. I mean how to decide the name and all. So that comes under nomenclature. So this is what we call a functional group. Now what happens? What if, and you have to make one more thing sure, that the valencies and all should be satisfied. Otherwise the compound will not be stable. So you may imagine now what happens. Earlier it was C2H6 ethane, there was a hydrogen atom here, and this time I want to remove it and I want to put a OH there. So if I put OH here, if I remove that hydrogen atom and put OH there, now first thing you always check the valency, okay? So anyway, till this part it was nothing changed, so valency is anyway satisfied. Oxygen has valency of 2. So one side hydrogen is connected, one side carbon is connected. So oxygen valency is of course satisfied. Hydrogen has a valency of 1, so it is sharing 1 electron with the oxygen, that is also satisfied. Carbon has a valency of 4, so 1, 2, 3. One more valency was left, that is been satisfied by the oxygen itself. So this is also a stable atom. Now when I have added OH, OH is nothing but the functional group for alcohol. So the name will change here and it will become ethanol. So the name will change to ethanol. Formula will become C2H5OH. Okay. A lot of people write it as CHC. If you see C2H5OH or CH3CH2OH, these both are exactly the same thing. They both are nothing but ethanol only. So it's just a different way of writing. Some people write all the carbon and hydrogen and OH group. Functional group we always write together. You never write this as C2H6O. You don't write it like this. There's a reason why we don't write it. You'll say, okay, hydrogen, 5 hydrogen is here, one more hydrogen is here. Why can't I write it as H6O? That's right, but if you write this, this is the functional group OH, which clearly says that it's an alcoholic element or alcoholic compound. Now, if you keep it like this, it will be really confusing to see that which functional group it belongs to. So that's why we always, this way we never write, we always write like this or this, they both are fine. Some people write like this because this clearly tells you the structure. If you see, CH3 is here, CH2 is here, and then OH. So CH3, CH2, OH. So some people write like structural way also, that's also right, but not very much required. So that is fine. So functional group is basically these kind of elements which can replace a hydrogen atom into the compound and change their properties. So such things, such add-ons or replacements are called the functional group. That is what functional group means. Now we'll read more on this. So these heteroatoms and the group containing these confer specific property to the compound. So what they are saying is these heteroatoms, what you are adding to the group, so they confer or they basically change the specific property to the compound. So they change the properties of the compound regardless of the length and nature of the carbon chain, and hence are called functional group. So it doesn't matter how long or how small the carbon chain is. No matter, even if it is like here the carbon chain was just 2 carbons were there. What if I'd have taken some pentane with 5 carbons, right? So if you take pentane here, what is the formula of pentane? It's C5H12. So C5H12 is pentane. Pentane. Okay. Yeah. So this is pentane. Now in this also, if I make the structure, it will look like it will look like this. So this is a 5 carbon chain element, pentane. Now here also, if I remove this H and write it OH, so it will change the property of a pentane and it will become pentanol. And it will again exhibit the alcoholic property. Doesn't mean that there were 5 carbons, so the alcoholic property will not be dominant. It's not like that. Here again, the alcoholic property will overcome the properties of pentane. So that alcoholic property will be the primary one here. Some important functional groups are given in table 4.3. So if you look at table 4.3, the major functional groups are already given here. So when we substitute chlorine or bromine, these are the halogen groups. So how the names and all come, we'll talk about it later. If we put OH, it gives you alcohol, alcoholic group. If you put COH at the end, okay, so here we replace from the carbon atom itself. Okay, so how we do it in aldehyde case, we'll see. Again, same happens if the carbon is replaced with C and double bond O, it's a ketone group, and then COOH is a carboxylic group. So how the names and all will be given, we'll see about it. Now, the functional group is attached to the carbon chain through this valency by changing one hydrogen atom or atoms. So normally functional groups will replace the hydrogen atom, and then in place of hydrogen atom, this new group of different atoms will be joined and it will change the property. That's how we call it. Why we call it functional group? Because it changes the functionality of the previous compound. What was it before they joined? So that's why we call it functional group, because they only decide the function or the properties of the new compound. Now, homologous series, you would have understood, homologous series is nothing but CH2 when we keep adding. So it keep going further. It keep increasing the number of carbon into the chain. And if you see like methane, ethane, propane, butane, it's all difference of CH2 only, or just not methane, ethane only. If you go for methane or methene and propene and butene or butane, everywhere if you observe the difference is only of CH2. So I'll show you that homologous series also once. So what it means is something like this. Okay, let's talk about first methane. The formula of methane is CH4. Ethane. The formula of ethane is C2H6. Propane. It's C3H8. Butane. It's C4H10. Pentane. It will keep going if you want to. It will C5H12.
The
So if you-
same for alkenes and alkynes also.
Yes, it will be. I will go there also. These are all nothing but the alkanes, right? So if you see CH2 and CH6, there's a difference of CH2. Basically, in this, if you add CH2, you'll reach here. In this, if you add CH2, you'll reach here. In this, if you add CH2, you'll reach here. This is what I can observe. Now, I'll talk about alkene. Alkenes. So methane is not possible, ideally, because it will not satisfy the valency. So the first one will be ethene. Ethene formula is C2H4. Propene is C3H6. Butene is C4H8.
So I can't remember these formulas, but if you give me the name, I can draw the structure and then I can maybe give the formula.
I'll tell you the way to remember the formulas. It's very easy. I'll tell you not the trick, basically a way to remember. So here also, if you see, there is a difference of CH2. Here also, if you add CH2, you'll reach to propene to butene. So these are nothing but they are all differ by CH2, one carbon and two hydrogen atoms. So when you keep doing that, you keep going to the next carbon chain, basically. That's why we call it homologous series. Homologous means they are all same kind of series, just one carbon and two hydrogen you add and you go to the next carbon chain compound. Okay, how to remember it, I'll tell you. Now, okay.
Is it that formula that for alkenes and alkynes, Cn into that H2n plus 2 and 2n
Yes,
and for
yes,
alk-
yes,
oh,
yes. That is there. And apart from that, how we give the names. So just one overview. Hopefully it will help you. So you remember it as like alkane, alkene, alkyne. Now, alkane formula is CnH2n plus 2, CnH2n,
2n
CnH2n minus 2.
minus.
It's simple to remember. It's almost like whatever it's here, it's CnH2n plus 2, CnH2n, CnH. Basically, it's in a decreasing order. 2n plus 2, 2n, 2n minus 2. Right? Now, what you have to remember here is just remember the name, I mean the series, like methane, ethane, propane, at least till 5, butane, pentane. After that, hexane and other comes. Heptane and all those things are there. Octane is there, nanone is there, dectane is there, whatever. So first 5. Just remember the series: methane, ethane, propane, butane, pentane. Now you start with C1. You put n value as 1. So if n is 1, h will become 2 into 1 plus 2, 4. So you write 4. So anyway, C1 we don't write it, so we write it as CH4. Next, you put n equal to 2. If you put n equal to 2, so 2 to the 4 plus 2, 6. C2H6. Or basically keep doubling this number, whatever you're writing, keep doubling and add 2. Simple. If I write 3, 3 to the 6 plus 2 is 8. If I write 4, 4 to the 8 plus 2, 10. If I write 5, 5 to the 10, 12. Right? So this is easy. Done. If you remember these 5 names, now what happens between alkane and alkene? It ends with ane and it ends with ene. That's the only difference. So wherever you see this ane, okay, so that you just convert into ene. That's it. So now you'll say methene, but methene is not possible. The reason is if you put carbon as 1, hydrogen as 2, basically if you, because in methane the carbon number, the number of carbon atoms should be 1. If I put number of carbon atom as 1, hydrogen H2N will become 2. CH2 is not stable because it is not satisfying the valency. One carbon atom, one hydrogen, one hydrogen. It is not satisfying. There will be 2 more valency left for the carbon. So this is not possible. So just remember that in alkene group, it starts with ethene only. Now why we put the name ethene? The name itself says it's alkene, and ethane, you know, the number of carbons are 2. So if number of carbons are 2, so I'll write it as C2H4. So in alkene, what happens? Whatever number you're writing, double the number of hydrogen. That's it. So after ethene, it will be propene. So propene will be C3H6. Then what? Butene. So butene will be C4H8. Then it will be what? Propene. Propene will be C5H10. Same way, easy. Now we'll come to alkyne group. In alkyne group, again, methane is not possible because if I put n equal to 1 here, so it will give me C, H, 2 ones are 2 and 2 minus 2 is 0. So basically no hydrogen. So just C is like, of course, not at all stable alone without making any other bonds. So here also it starts with the second number only, but here the name will become ethyne. Now the moment you see YNE at the end, you can understand it's alkyne group.
Triple bond.
Yes. So here it will start from C2. Now if you put 2, just double it and subtract 2. So 2 2s are 4, 4 minus 2 is 2. So C2H2. So next will be ethyne, then propyne. Now propyne is nothing but C3. Double of 3 is 6. 6 minus 2 is 4. C3H4. Then butyne. So C4H. 4 to the 8. So 6 here. Then what? Pentyne. So pentyne will be C5, 5 to the 10, H8. So it will become C5H8. So it's easy to remember. See, that's why I ask you remember this series: methane, ethane, propane, butane, pentane, in this order. So if you remember it, the moment you see ANE at the end, it's alkane group. ENE at the end, alkene group. YNE, alkyne group. Done. Now, if you know the order like methane, ethane, propane, butane, and pentane, so you know methane comes 1 carbon, ethane is 2 carbon, propane is 3 carbon, butane is 4 carbon, and pentane is 5 carbon. Just put the number of carbon as n, and then you will get the other numbers. Only thing in alkane group, methane is there. In alkene and alkyne group, it will not possible because of the stability and valencies. So that's how we decide. And if you see, all these are between these two, there's a difference of CS2, CS2, CS2. Everywhere, if you see, the next carbon chain has a difference of CS2 only. That's why we call it homologous series.
So it means all homologous series will have difference of CH2.
Yes, if it is a hydrocarbon, if it is some other group, it might have some other homologous series. It's not like CS2 is the only homologous series. There is other homologous series also, but for you it will not come. How much I know, it's not in them.
Okay. Also, sir, I was having a doubt in isomers, structural isomers. So alkynes can't have isomers, right? How can alkynes have isomers?
No, it can have, I guess, 3 bonds. Okay, it's a unsaturated one, right? So
Yes, yes.
no, I think we can have. It's not like that. We'll come there.
Can you please tell an example?
Yeah, sure. First, you want to go with the isomers or the nomenclature?
We go with isomers. Sir.
Okay. Let's go to your structural isomers. Now in isomers, what happens is you can't do it until what? Until propane you can't do it. First thing.
Yeah. Yeah.
So the reason behind is that no matter however you shift it, you change it, it will always be like one line only, I'll tell you.
Yeah, because even if you reverse it, it will remain same only.
Yes. So the branching will not be possible basically.
Also, sir, first I had doubt with this structural isomers about alkynes. Then I was having in butane. Shouldn't see we look for the longest chain, right? So shouldn't it be propane something? It can be propane something.
If that way you'll see, propane has 3 carbons.
No, I'm talking about butane.
Huh.
Wait,
Okay,
yeah, I got it. It's named 2-methyl propane.
Yeah. Okay. So you're telling me butane can be written as 2-methyl propane. Why?
Yes.
Okay, I'll tell you about it. So butane is nothing but C4H10.
Yes.
Okay. Now imagine a structure is like this with the branch. This is the structure I think you're talking about as 2-methyl, right? Three, 5, 8, 9, 10, 11. No, 3, 6. Okay, something is not right. Okay, this carbon has only 2 valence. 1, 2, 3. So one more will come, no? 1 second. This is 3. Oh, this I've made 5. So this hydrogen will not be there. Okay. Now it's fine. 10. This carbon 1, 2, 3, 4 is satisfied. So why we call it 2-methyl, right?
So I think, see, I may be wrong, but I saw YouTube video and what I understood was that there's a methyl group attached to the second carbon, something like that.
Exactly. That's the reason. That's right.
Because anything ending with YL are just extra attachments to the main chain.
Correct.
So methyl will be with
if
one
ethane
carbon.
if ethane is attached, it will be ethyl. This is basically ethyl is nothing but methyl is nothing but CS3. Any carbon at any methane, ethane, propane, butane, whatever you are writing, if one hydrogen you remove, it becomes YL, ethyl, methyl, propyl, like that. Okay, so CS3 is called methyl. Okay, so you can remember it like this. Methane becomes methyl if one hydrogen is removed. Propane becomes propyl if one hydrogen is removed. If it is C2H5, so it's basically propyl, ethyl. Okay, now this one, I'll tell you anyway, what they have told in the YouTube is right, but I'll just show you once also, since we have done this. So now which chain you want to make? See, 1, 2, 3, 1, 2, 3, or which one?
Anyone is fine.
Anyone. It's gonna be same only. So 1, 2, 3, right? Okay, I'll write it in, I'll just highlight it. 1, 2, 3. I'll make the same structure little straight for you now. What will I do is the same structure, this carbon which has been branched like this, I want to make it straight. Let this come down. Won't it look like C, C, C? 1, 2, and third C I have written. First C has 3 hydrogens, 3 hydrogens done. Second C has 1 hydrogen, okay, 1 hydrogen. Third C has again 3 hydrogens, 1, 2, 3, and then from second C there is a branch coming like this with a C with 3H. So the same structure, I have made it a little more straight. It's the same thing. Rather than showing it as a branch, I have done it as a 90-degree thing. Now, if you count it as 1, 2, 3, so at number 2, you have a methyl group attached. So that's why we put a number 2. Methyl, we write it because it's methyl attached. And now the longest chain what I'm getting has 3 carbon. So 3 carbon is nothing but propane. So 2-methyl propane. Like this we write it. Understood?
Yes, sir. Okay.
Okay. So, okay, now you are asking that if alkynes have branching possible or yeah, isomers possible or not. Okay. So let's take some example. Let's see if it is possible or not. Nomenclature, work on it, because nomenclature usually comes. If carbonyl compounds are coming, then there'll be 2 mark or three. Yeah, not 3, but 2 marks questions will be there just to tell you the name. Just you have to tell the name there. Okay. So if I take C4H8 for example, butane. So the structure will look like 3, 4. Okay, something is missing here. 1, 2, 3, 4 carbons. This carbon valency 4, this carbon valency 4, this carbon valency 4, this carbon valency 4. So it's C4. Oh, I've made for alkene. It's alkyne. So C4H6. Fine. Done. Now in this, if we have to do the branching, so the middle carbon does not have valencies left. So if I shift this as double bond, okay, it might not happen in butane, but it might happen in pentyne with 5 carbons. We'll check with pentyne also. So if we see it's C5H8, so what difference will happen? That one more carbon, hydrogen, hydrogen, hydrogen. 3, 4, 5, 6, 7, 8. Fine. Okay, so now if I put so there it's basically the longest chain has 5. So if somewhere I have to change it, what if I shift the double bond here and triple bond there? No, it's possible. I'm sure it's possible. It should be C triple bond C, 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 C. Let's give it like this. It will have only one H, 3 and 1, 4. This is 4 already satisfied. This has 2, so H and H. And this carbon I'll shift here. So in this case, this will have H, 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 C, H, H, H. So it's 3, 6, 7, 8. Yes, it is possible. No? See? Okay. It is C5H8 again. It is your butane. But if you see, there is a branching happened here. So if this one I have to name, what name should I give? The minimum number should have the branching, right? When you take the longest chain, so you have to make sure that the least number has the branching happen. So I have to take the numbers in this direction this time. So it will be something like 1, 2, 3, 4. At 2 there is a methyl group attached in the chain. So I'll write it as what? 2 methyl and methane propane. It's 4, no? Methane propane butane. So 2 methyl butane.
2 methyl butane. So how is it butane?
Because it has 4 carbons.
Oh yeah, okay.
In the longest chain. So yes, it is branching is possible. There's nothing like in alkynes it's not possible.
Okay.
Only thing like normally what happens in alkenes and all, it starts at butane from 4 carbons. Here it starts from 5 carbons. From pentane basically, pentane series basically. Okay. Give me just 1 second. Okay, so this was about your isomers. Then we have covered about your functional groups, homologous series. Let's see what is next. So we were
Sir,
talking.
also,
Mhm.
there's one more thing. So I've noticed that in a lot of questions and all, not in NCERT, they've named N-hexane, N-butane. So I've figured out that N means normal, which means all the carbon atoms are in a straight chain. Is that
Yes,
right?
yes, that's right.
Okay.
When there is basically a normal hexane is called N-hexane. That's it. Okay, about one more thing I wanted to tell you. So nomenclature. Yeah. So this pink table, which is table 4.4, gives you a lot of ideas. If you see what happens, basically table 4.3 and 4.4, they would have given together actually. Anyway, so I'll write it on the board and show you what I'm trying to say. Table 4.3, it says chlorine or for halogen groups, basically for halogen groups you add either chlorine or bromine. That is for halogen groups. If you look for alcohol groups, it is OH. Next is what? Aldehyde groups, it's COH. So aldehyde, it's C double bond O single bond H. Then after that, what ketone is there? Carbonyl ketone is there. C O. And then you have carboxylic group. Carboxylic acid is usually called, no? Yeah. So carboxylic acid. Here you have COOH. So C, if double bond O and then single bond OH. Okay. Now, these are the heteroatoms basically for every group. Now, if I go to table 4.4, it gets stuck. Okay. So now, see what happens. First thing, if in any atom, we'll take any one atom and we'll check with everything. Let's say I want to take C3H8. What is it? Propane. Now, propane structure, you know, it will look like CCC, H, H, H. So this is nothing but your propane. Now, imagine this H I removed, and in place of H, I want to put the first chlorine. So I removed this H and I have put a chlorine here in place of that H. This same propane will now be called, so if you look at table 4.4, what is written? Prefix chloro or bromo. That means in propane name, the earlier name was propane, you have to put a prefix. Halogen group is the only one where prefix comes. Everywhere else suffix comes. So prefix as chloro. So since I have put Cl, chlorine of course, so chloro propane I'll call it. If I would have put bromine, I would have called bromopropane. So chloro and bromo only comes in this as the suffix. As the suffix, basically before the name of the original compound or hydrocarbon, and it does not change in the name further. This is how we put the name. Now, if I would have put here Br rather than putting Cl, if I would have put Br, so the same thing I would have called it as bromopropane. So this is about the So this is how we put the name for the halogen groups. Now we'll talk about alcohol group. So in alcohol group, what happens and how we put the name. Now imagine it was hydrogen before. This time in place of hydrogen, I removed and I have put OH. Because if you see, alcohol has a functional group as OH. Now if you look at your table 4.4, alcohol says in alcohol, we put a suffix of OL. Now whenever we put suffix of OL, we remove this last E. So in place of E, you put OL. L. So if it is propane before, the new name will become propanol. Propanol. So propanol is nothing but, with the name itself you can say it's an alcohol group because it ends with OL, and it's made up of propane and the alcohol. So you can make the formula also, that in your C3H7OH. This is nothing but propanol. So with the name, how you can first thing, the name itself tells you about which group it belongs to and what will be the formula. Okay, so now we'll see further. That is how we put with alcohol. Aldehyde we talk about now. Now aldehyde, if you see, aldehyde has COH comes at the end, right?
Come here.
So when we talk about COH, a lot of people get confused here, that we every time say we replace the hydrogen atom, we replace the hydrogen atom, every time we say. So will it be like earlier if it was like this, earlier if my propane looked this, so do we remove this hydrogen and we put CHO? No, it's wrong. This is not what we do here. Because if I do this, the propane will become butane. It will have 4 carbons into it. So we can't do that. We can't play with the number of carbon
Sir,
atoms.
can you repeat again?
Yeah, what I was telling here is.
Sir, can you repeat again?
Yeah, sure. So this was my propane, right? Simple propane. In the halogen group, what I saw, I removed this hydrogen, put chlorine or bromine. In alcohol group, what I saw, I removed this hydrogen and put OH as per the functional group. Now, if you come to aldehyde, the functional group is COH. C double bond O, single bond H. Okay. So, a lot of people here, they get confused with that functional groups, that here also, do we remove, because whatever the functional group, we are removing the hydrogen atom and we are putting that in place of hydrogen atom. So here also, do we remove this hydrogen atom and we put like CHO? Is it what we do? If we convert a propane into aldehyde group? No, we do not do that, because if I do that, number of carbon atoms will change. Number of carbon atoms will become 4. It will go into butane series basically. So how do we use aldehyde group? So if
So
you
basically
see,
we just put H and double bond O rather than this.
So yeah, in this what we do is we remove 2 of the hydrogen atoms and put a O. That's it. So see, CHO is coming at the end. Yes, it is coming, and it becomes the aldehyde group. Now if you refer to your table 4.4, it says aldehyde groups gives you the suffix of Al. So again I'll remove this E and the name will become propanol. Al in place of E. So the moment you see the name as propanol or butanol or ethanol, anything like this, so you should first think it belongs to the aldehyde group. If it belongs to the aldehyde group, the last is gonna be CHO. And if it is propane, so 1 carbon is already been considered as CHO, so remaining 2 are good. So this propanol formula, how we write it as C2H5CHO. We write it like this. Functional group we always write together. We don't write it like C3H6O. We don't do that, because in this case you'll not be able to decide the functional group. So functional group we always keep it at the end. So that is about the aldehyde. Basically what you do is you write this whole thing and then the functional group. That's it.
Oh, okay. But we have to be careful when doing aldehyde.
Yeah, aldehyde, ketone and carboxylic acid, all three, because all three has carbon atoms. So if you come to ketone, it has C double bond O comes into picture, right? So now what will you do? Since C double bond O, and if you see these 2 sides, it has valencies open. So now I'll again come back to my normal propane first. So in this what happens, in this what happens is, we can't put that double bond O here. I mean, we can put double bond O here also, or with any carbon, but we have to check the valencies. If I'm putting double bond O here at the end, basically it will make COH, and that will become aldehyde group. So in this case what we do, somewhere in the middle we put it like this. Why do we do that? Is because the carbon I'm attaching, that oxygen, as per ketone it should be CO. So if I'm attaching it like this, So the remaining two sides should have carbon only. It should not have hydrogen, because if it will come as hydrogen, it will go to aldehyde group again. It will become CHO again.
So can you draw that and explain?
Yeah. Imagine rather than this carbon, I want to put double bond O at this carbon, right? The third carbon. So see how will
Yes.
it look. So if it is C, 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 H, 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 H. This is a normal propane. Now if I want to put it in this carbon, I'll remove two hydrogens and I'll put double bond O. Doesn't it look like aldehyde? C double bond OH together?
Yes.
So we can't do that. Because if you write like this, it will become aldehyde group, because CHO, if it is coming together, CHO, it's aldehyde group. So you have to make sure that C and O should not be coming with the same, the same carbon should not be in touch with hydrogen. So here if you see, it is only CO and the other carbon atoms are there, hydrogen is not there. So now about its name. So looking at this structure, you can easily say it's nothing but ketone. If you look at ketone, it gives you O and E at the end. So same way, remove this E and write it as propanol.
So is methanol possible?
No, methanol is not possible.
What about
ethanol? Ethanol, it's C2. So 2 carbons, no, it's not possible again. With 3 only it can start. If you try with 2, see, I'll show you. This is your ethane basically, C2H6. Now where will I put? Both the carbons are at the end only. If I remove these two and put double bond O, it's again going to ketones aldehyde series. If I remove these two and then put double bond O, again it looks like a aldehyde group, so it's not possible there.
Oh.
Okay.
I need to practice a lot on this.
It's all about, that's what I'm telling you, table 4.3 and 4.4, if you combine and see, that gives you a better idea. Since they've given on two different places, nobody combines it and then studies. Okay. Now we'll come at last carboxylic acid. So in carboxylic acid, if you see, the suffix comes as what? Oic acid, I guess. Yes, it should be oic acid. 1 second.
So why in the ending they have given alkene and alkyne?
Simply in the table they have given, already you know about alkene and alkyne though. They just wanted not to miss those two things. So anyway, now if I propane only, if I talk about, so propane normal structure, okay, I've erased it. So it was C3H, H, 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 and H. So this was my propane. Now if you see, it should be C double bond O and single bond OH. So what will I do is, I'll remove these two and I'll put double bond O, and here I'll put a OH compound there. So now if you see, if it is ending with COOH, it will be carboxylic acid. And again, this name also, we don't write it like C123. So C3H12345 H6O2. No, we never write like this. Always like how we were doing before, it will be written like C2H5 COOH. The functional group should be separately written. So if you write like this anyway, COOH, you can say it's carboxylic acid. Carboxylic acid, if you see, it gives you the suffix as oic. So again, remove this E, put OIC acid. So I'll write it as, yes.
So how can we represent the structure into a different form? Like in this book, suppose you have butane, they have instead of spreading out all the hydrogens, they have condensed it and written as CH3, then single bond, then CH, then single bond. Yeah.
Okay. Yeah.
So how can you write this like that?
Why can't we do that? See, what you can do is this one only. If I write like, you write like this.
Yeah.
That's it. CS3, CH2, CS3, CH2, COOH. Yes. That's also the same thing. It's again propanoic acid only.
But isn't that one easier?
Both are right, it's just a different way of writing. It doesn't I mean, it has no such rule that you have to write this or that. Both are correct basically. Only rule says that the functional group should be at the end. Now this thing, however you want to arrange, it's your choice. This is basically what people do is, as per every carbon they separate. So this carbon has 3 hydrogens, so they write it as CH3. Next carbon has 2, so that they write it as CH2, and then the final carbon has 1
Should
oxygen
we
and 1
put
oxygen.
those bonds in between?
It's again, it's not required, it's up to you. See, I'll just show you. If you write like CH3 CH2 COOH, so it's always better to put a bond, because this is more like a structural formula you're writing as per the structure you're writing. So we write the single bond, or if you don't want to put the bond, it will not look good. CH3 CH2 COOH, it will be like more confusing. So rather than writing this, if you don't want to put the bond, you write this thing only. That's always
Okay,
better.
okay.
But if you are breaking every carbon, then it's better to put the bond. That's
Okay.
it. So that was about your nomenclature also done. So now you know, looking at the name, you can say that which group it belongs to with the suffix or the prefix. Prefix is only in halogen, so rest everything is suffix only. So you have to remember, alcohol group, OL comes, aldehyde group, AL comes, ketone group, your ONE comes, and then carboxylic acid, oic acid comes at the end. So these suffix you have to remember, and then now you can tell anything, any formula, any structure you can make. That's it. So if you remember, I mean, if out of blue, imagine somebody will ask you that what is okay. For
Sir,
example,
yesterday I saw this compound name, but it's I think it's pretty like elaborated, not for me, but I wanted to try.
okay,
Yes,
you can
yes.
try, no problem. You can even, if you're if you are seeing it somewhere, you can send me the link. If you want me to explain you some of the videos, YouTube videos, or any videos, I can do that. Or if you want any particular name only to be done, it's better if we can, if you any video you're not understanding, you let me know, we'll even do that. So for example, butanol, if somebody will ask what is a structure of butanol or what is the formula of butanol, how will I decide? First thing, I'll look at this Al. Now Al comes as a suffix for what? Aldehyde. So with this Al, I'll reach to aldehyde, and it's easy to remember, Al, aldehyde. But don't get confused with alcohol also. Alcohol also has Al, but Al comes suffix, that you have to remember anyway. So now Al, aldehyde, CHO. In butane, I know how many methanes and propane butane. 4 carbons. 1 carbon is already used here. So what will I do is, I'll first make 4 carbons, because it's butane. So butane will have 4 carbons. But the last carbon I'll give that. So H double bond O. Because it's since aldehyde group, this has to come. I have done that. Now remaining, I'll just satisfy the valency with hydrogen, which will come like this. And looking at this, you can easily say it's nothing but C3H7CHO. So the formula you can write C3H7CHO, or if you want like how you in structural formulas, you can write it as CH3 CH2 CH2 CH2. This is also same thing, butanol. Okay.
Okay, sir, I have an example. If you can help me with that.
Yeah. Tell me.
The name is 4-ethyl
One
dash
second.
3, 5 dimethyl nonane
Okay. Tell me 4.
dash
Hmm.
ethyl dash
Mm-hmm.
3,
Hmm.
5 dash
Okay.
dimethyl nonane.
Dimethyl nonane. Okay.
Nonane, yes.
Yeah. Nonane is carbon chain 9.
9,
Yeah.
yeah.
Now, so what they are telling is nonene, if they are giving, that means the longest chain has 9 carbons, right? Where the fourth has a ethyl attachment, 3 and 5 has a methyl attachment, and that's it. So how will you make it? First thing, nonene. So make 9 carbons, 1 2 3 4 5 6 7 8 9. Now imagine I want to go in this series only 1 2 3 4 till 9. So 1 2 3, at 3 you have 1 methyl, So here you put one methyl group. So if you want, you can write it like this, or if you don't want to write so much also, you can simply just write it here as CH3.
Yes.
That's also fine. Now at 3 and at 5 you have CH3. Done. At 4 you have a ethyl group. So here you write it as ethyl is C2H5. Done. And then remaining things you just balance their valencies. So here I'll put hydrogen, 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 hydrogen. This has 3 done, so fourth one is hydrogen. This has again 3 done, fourth is a hydrogen. This has 3 done, one more hydrogen, 2 more hydrogen.
So can it be 3,5 trimethyl?
No, not possible.
No, right? Okay.
3,5 means at 3 and 5,
Two,
di means
yeah.
2 methyls are there. If you put tri, in that case there should be one more number. So this is how it look like. That's it.
Okay. Okay, sir.
Okay, fine.
It wasn't that complicated, but okay.
It's not complicated. See, it's all about practice, and it's basically following certain rules. That's it. And the rules are not so many also. It's not so confusing also. It's just like if you do some 5, 6, 10 complicated ones, no? Then you'll be able to. So this was about Carbon's compound, and that's it. Nomenclature is there. After nomenclature, you have chemical properties of carbon compounds, combustion and all. That's fine. So combustion is basically it's basically in presence of oxygen when carbon gets converted into carbon dioxide.
Yeah.
Oxidation, so many times you have studied already. Addition reaction, when some catalyst is added in the reaction. Substitute reaction, it's like displacement, but not exactly displacement, but something similar to that. Then you have ethanol and ethanoic acid. This 4.4 is one of the important parts. Some important carbon compounds, ethanol and ethanoic acid. So basically hydrocarbons, there are so many other hydrocarbons also which are important, but ethanol and ethanoic is very much into market. Basically it's commercially used, both of them.
What are they? I mean, like, what can ethanol be used for?
That is what it's talking about. Ethanol is used as alcohol, what people usually drink. So in that, ethanol itself says it's alcoholic element, right? OL at the end, suffix is OL.
Yes.
So it's a alcoholic element, and nobody drinks it raw. If it will be like lethal if anybody does. So that's what the first property of ethanol they are telling, and what is the formula of ethanol they have given. And then further, if you see its reactions, so sometimes here from this particular topic the questions will come like, what is the reaction of ethanol and sodium, or so basically it's not much also. In if you just read it once, it will be enough. That's it. So about ethanol and ethanoic acid is it's acetic acid basically. So it is used to making vinegar and all that. Vinegar, whatever you see at home, what we use in putting in our food or anything. So it in that, what happens, there'll be water, and like in 100 ml of water, around 10 ml or even less than that acetic acid they put. That's basically ethanoic acid. So they put that in 100 ml of water, some 10 ml or 9 ml, they will just pour the acetic acid, and that is what we call it vinegar in our day-to-day life. So that is their esterification reaction. So that is it creates basically ester. So that's why we call it esterification reaction. So that also sometimes comes in the exam. What is esterification reaction?
What is ester?
Ester is again one more compound, like how we have halogens and like how we have aldehyde group. Ester is itself is one more group, but ester basically belongs under it should belong under ketone, I guess. Ester is nothing but okay, it's a compound. It's not a group. I can't call it a separate group, but it's a compound which has been used in
Making perfume.
Perfumes, yes. I think even in laughing gas they use it. That I'm not sure. I have to see. Perfume, yes, they use ester.
Laughing gas actually exists.
Yes,
Oh,
laughing
I
gas
don't
is,
know.
no, it actually exists now, and
Does it
especially
actually make you laugh?
yeah, you will not be able to stop your laugh. You know that you are laughing without any reason since you have inhaled a gas. In fact, your mind will be conscious. It's like you know that you have inhaled a gas and that's why you are laughing. But even if that sometimes comes and beat you or slaps you or whatever or pokes you also, you'll not get angry at that time. You'll keep laughing for a certain time for like um, almost like 30 to 40 minutes. Depends how much you have
That's a
inhaled.
lot.
Yeah. So it
Oh.
happens. You can, yeah, that is there.
I want to try if it's available.
It's not available for the public. It's usually at a lot of crowd and all people use it. Earlier it was getting used more, but now it's more like uh,
Banned.
not banned. Now also it's not banned for the police people, but it's like it was not very effective. It was like imagine some people are doing some uh, illegal rally and police wants to stop
Yeah.
them, so they'll barricade them, and earlier they used to throw the laughing gas. Now also they do, but the frequency is very less, so they'll just throw the laughing gas. But then what they saw is like for half an hour or 40 minutes everyone will be laughing and then again they'll start with the rally, so it was not very effective. So now they
Oh.
completely do it other way around. They were just like lathi charge or other methods they use.
Mm.
But now also if it is a small crowd they go with the laughing gas, but that is there, it's
Oh.
not banned and all. Soaps and detergents you have already studied earlier also, I think, Michelle's and all. So
Yeah. And
hydrophilic
metals
hydrogen,
and
this
all.
is, yeah, this is from it. So this is all in carbonates compound, and questions mainly comes from in this chapter is bond, second is nomenclature, third is yeah, second is nomenclature, third is from the properties of ethanol and ethanoic acid, and fourth from soaps and all it comes, but it comes less, but 1 mark or 2 marks it might
Soap
come.
is easy, but sir, can you explain these reactions?
Okay, which one?
Esterification reaction and the ones following that.
Okay, yeah, I'll go there. Okay, so esterification, what happens is ethanoic acid and ethanol, when they combine together, they give you ester and water. That's it. So this particular reaction is called esterification reaction. And ester is normally used in making perfumes. No, yeah, it's a sweet smelling substance, so it's been used to making perfumes and flavoring agents. Okay, yeah. So I'll just show you this reaction is not something big. It's it's
Oh,
basically.
and
Mhm,
what is this? It's on treating with sodium hydroxide, which is an
mhm.
alkali. The ester is converted back to alcohol and sodium salt of carboxylic acid.
Yeah. So if ester you react with sodium hydroxide, that is NaOH whole twice, which is an alkali, so the ester will be converted back to alcohol. Alcohol in the sense ethanol, alcohol and sodium salt of carboxylic acid. Sodium salt of carboxylic acid means it will be CH3CONA. That is what it is. Sodium salt of carboxylic acid. So here with the carboxylic acid, they mean ethanoic acid, simple. So it will be what? CS3, ethanoic, methane, ethane. So two carbons only it is possible. So it will become CS3COONA. That's it.
Oh,
So if you treat it with NaOH whole twice, you will get your alcohol back, that is ethanol, along with CS3CONA. So basically that OH twice will be combined with the alcohol and the remaining Na will come here and join. That's it. Okay, what is the next reaction in this USA?
reaction with the base.
Uh, where did it go? Purification, ethanol, ethanoic, huh? Okay, so after this, what reaction is there followed by this? Okay, yeah, it's CS3CO, C2H5, NaOH has been reacted, and then it's C2H5OH. Oh, the same thing. No, I didn't come to this page, but that is what I've written. CS3CONA. Yeah, and
Yeah.
C2H5OH is nothing but your ethanol.
Okay. Okay.
So these reactions are important, like even in the acid base and not acid base, metal and non-metals, and acid base and salt. Both these chapters, there's a lot of reactions are there. Even those reactions comes always. So make a note of it. So when I was doing it with Arundhati, when I taught her that chapter, so at the end of the chapter, we made note of all those reactions as one place, a
It's in
summary of them.
second chapter.
Yeah. So if you want, you can check with her. She'll have. If not, even you can write
Yeah.
it on your own. It's not a big deal. All the reactions.
Acid, bases, and salt.
Yes. So all the acid
Okay.
reactions at one place, all the base reaction at one place. Salt doesn't have much reactions, few of them, and then finally the end of that chapter has uh, baking soda, washing soda, then
Yeah.
plaster of Paris, gypsum. So these all formulas and their reactions. So that also comes, and their uses we have not written. We have written all the reactions, but question comes: how is plaster of Paris has been formed, and what is the use of it, or how is
Yeah,
washing?
I have written all those reactions in my notebook.
Okay, that's good. So that is there from this chapter. Now what?
So I have a feeling that this will get really elaborated and hard in 11th grade. This chapter.
11th you will have, like, see, chemistry will be distributed into multiple different sections. Different sections, when I say, I mean that, one second. One second, just give me a second, I'll be back.
Yeah.
Okay, yeah, sorry. So uh, in 11th, once you enter, so chemistry will be divided into three different parts, which is physical chemistry, organic chemistry, and inorganic.
Physical chemistry?
Yeah, there is physical chemistry, organic, and inorganic. So there are three different parts of, like in biology also gets distributed further, not in 11th, 12th, but zoology and botany, right?
Yeah.
So same way, when your chemistry gets distributed into physical chemistry, organic chemistry, inorganic chemistry. So that is there. So that will come slowly, but it will not be difficult. It's not going to be very complicated. See, if you're doing your 10th and the way you're doing it's good. It's not like you're just mugging it up or you're just going through the chapters just to get marks, but you're trying to understand it at your best level, that okay, why it's happening, or if this will happen, what name will come. Nomenclature and all will again come in 11th, and that will be even more big complex compounds. But again, the basics, how much you know, it's enough to for you to go to 11th and in fact solve those nomenclature as well. So
Oh.
there you'll have beauty. There is something called butane, not butane. Okay, I was so much into alkene. I just that name only I'm not remember. It's one of the very important one. I was telling someone some other day. Okay, I forgot the name. I'll just tell you. It's basically like a ring, and so further a lot of things will become even shorter. Like wherever you have CH2 and all, you don't have to write CH2, CH3. It will be already understood. So wherever you're putting anything in a hydrocarbon apart from C and H, that only you have to put a name. Like if you're putting chlorine or bromine or oxygen or anything like that. So there only you have to put a name. Rest with the bond only you can show that it's hydrocarbon. It will be there. It's not going to be complicated. It's okay. That's going to be slowly only rise up.
Okay.
So what you're going to do after 12th? I mean, it's long way. You might have not decided.
Yeah. No, I haven't.
Okay, so for now, 10th is about science you're going to take.
Yes.
Okay, that's good. So in the same DPS has 11, 12, no? Yeah.
Yeah, DPS.
So you will continue in DPS or president or any other school?
No, DPS only, DPS only.
That's fine.
Yeah. And also, sir,
Mm-hmm.
the general formula of these cyclic hydrocarbons, can you explain it?
Okay, sure. Let me
So the
go.
general formula of cycloalkanes is CnH2n, which is the same as that of alkene.
Alkene, yes. So see,
Oh.
cyclic compounds, what happens is, of course, with the name itself, it makes a cycle kind of structure, right? It makes a round structure. Like for your example, if you see 4.9b, so if you see 4.9b figure 4.9b, so it is C6H12, right? That is cyclohexane. We call it hexane, but since why we call it cyclohexane and why it's not
So is your
alkene?
video on?
No, video is not on.
Oh, okay.
I'm just referring with the book. I'll just share the screen for now.
Okay.
So if you look at figure 4.9b, it's called cyclohexane. The formula is C6H12. Now with the formula, you might think that it's nothing but alkene, C6H12, because N, CnH2n it is following. So you might call it as hexene also. So now it depends. Hexene and cyclohexane has the same formula. That's right. But if they ask you their structure is completely different, because if you are making hexene, you'll use a double bond and you'll make a straight carbon chain. But if they are calling cyclohexane, the structure will have like a
Cyclic. Yeah,
cyclic or
circle.
like a ring only. Sometimes we call it ring structure also, but anyway, if they're calling it a cyclic structure. In further, when you go to 11th, there is a chapter called hydrocarbons. I think it's in 11th or it's in 12th, that I don't remember, but it's in chemistry. I think it's in, I'm not sure, 11th or 12th somewhere. In that chapter, what all things you will study is in H2 when we make. So basically it's oxygen with 2 hydrogen. So far we know like oxygen has a valency of 2, hydrogen has a valency of 1. It's been satisfied and that's how H2O is made. That's right. There it will come like between oxygen and hydrogen, the bond which has been formed, that's covalent bond itself which is formed, what angle will it be? So it is somewhere around 109.5 degree angle. So that angles also you have to remember. What is the length of that bond? So it will be some picometers and all. So I think it's 152 picometers. So that will also come. Oh, you are writing the arrow?
Oh, yes. By mistake.
But how come you have the control? Okay.
I can.
Oh, I didn't know that you can. I mean, I thought like if I have to give you the control and then you can, but that's fine. So even those angles will come, the length of the bonds will come, how long will be the bond in which particular thing. In diamond is one of the very complicated bonding structure. So in that, how many bonds exist, what all are the elements used, what is the angle there, and then different bonds will have, there's a pi bond, there's a sigma bond.
Yeah,
So
sigma pi I was reading yesterday, but it got too complicated, so I left it.
yes, okay. So now I'll not suggest you, because even if you study also, it's not like you're gonna write in the exam. Though for your
Yeah.
knowledge, yes, you can. That's always there. So that those things will come into 11th and 12th. So it's not like it's gonna be very complicated. It's like a step up, of course. So step up, the same thing when you go to a next level. So you'll have some more uh, things will be added up in the same chapter. Like that, it will be. So this is done. What else? Carbonate compound is like completely done. And your NCRT.
So,
Okay, what about? Yeah, tell me.
what is the difference between skeletal formula and structural formula?
Keratin formula and the structural formula.
Yeah.
Tell me, where is keratin?
No, it's not written in this from YouTube video. So there's this YouTube video I saw, and she told that there are 4 ways in which a molecule can be represented. A molecular formula, structural formula, which is always derived from the Lewis structure.
Correct.
And then you have the condensed structural formula. Basically, you write CH3 instead of C and spread out H.
Correct. That's
And then you have skeletal formula. I didn't understand what skeletal formula was.
tell me the spelling because I must be knowing it, just that I'm not getting it. Tell me the spelling of skeletal.
Skeleton with
Oh, skeleton
AL.
formula.
Skeleton with AL in the ending
Okay.
instead of ON.
Okay, skeletal formula, something like that. Okay. So, our representation of molecule structure in which covalent bonds are. Yeah, that is what I was telling you. It will come in 12th. So, skeletal formula is nothing but we do not write CH2 and all those things. It is so understood that wherever there is a bend, that bend is nothing but a carbon atom, and along with that there is hydrogen atoms around it. So, okay, I'll just share my screen and I'll show you. You'll understand better. New share, and here. Okay. So now if you look at, okay, let's see this one, the one in the red. So this is called skeletal formula. This will come in your further classes 11, 12. So here what happens, if I look at the first circle here, a hexagon here basically. So this point where you can see the arrow is pointed, it means there is one carbon. That is one carbon is there. Now this side line is one hydrogen, this side there is double bond, that means two hydrogen is there. Again this place means there is one carbon. So we do not even write C and H at all. And wherever rather than H or C, if anything is coming, like here double bond O they have shown, that means this double bond O is coming. Double bond O comes under which group? It is, yeah, it's a ketone. Yeah. So there it's a ketone group has been attached. Here one ketone group has been attached. Here see, in place of carbon, if nitrogen is coming, so they have put here nitrogen, and if you see, it has three bonds only. So if you see the first one where the arrow, okay, where did I click it? If you see only the first bond here, so it will have four, 1, 2, 3, and one more carbon will be attached with the other carbon one here. So it is like a cyclic one, right? So here, and these are nothing but wedges, indicates a three-dimensional geometry. Three-dimensional means it's like, it's not horizontal in the sense, it's not basically a 2D figure, it's a 3D figure. So this bond is going either behind or up. So that is why they show it with the wedges. So that is the meaning of the wedges. That bond is basically either in a back side of the paper or the front side of the paper, it depends on the angle, and that is what this wedges has been shown. So this is called a yeah, your skeptical.
So I understood only half of what you told.
Okay, it's not difficult. It's in simple word, you can remember it as when we'll have long complicated formula, we'll not keep on explaining it as CH3, CH2. We'll not keep on writing carbons and hydrogen. We skip the carbon and hydrogen there, and it is just seen with the bonds together and the structure. So when the structure and the bonds together make a particular way of showing a molecule, it's called skeletal formula.
Okay.
That will come in 12th. It's not too far. That is.
Okay, so I'll just look for any more doubts that I might have inside.
Okay. Yeah, sure. Okay, so since we have done, okay, you're looking, then you can keep looking. I wanted to ask that since we have done maths with NCERT now, what is the status of RSA? Like, I know you might be doing parallelly RSA, but I also know that you might not be doing each and every questions of RSA, right?
So I did not do RSA.
Okay, okay, fine. But that is
I'm on chapter number 5 right now in RSA. I couldn't have time. I didn't have time to.
I understand. Yeah, that's of course, because the speed which we have gone with NCERT. So even in fact, I can't expect you to do RSA and NCERT both at the same time at that speed. Not possible. It is only possible if you leave all other subjects and only do maths, which is again not right. So RSA again will continue now. So you are in chapter 5. That's good. So we can continue from chapter 5, or if you want, we can start from chapter 1 itself as a revision. And I also heard your school had a test which was supposed to be like in this week, but it has been postponed to the end of July.
I don't know about that, but the teacher just told that there will be some exam conducted. We are having light processes and magnetic effects.
Yes, live
in the
processes
form
is
of MCQs.
only MCQs.
Yeah, because if it's online test, right? So they can't do subjective.
Okay, that's right. Or if they do subjective, their job will increase basically.
Yeah.
So I heard, okay, magnetism is coming. I knew life process is coming, that I know. And apart from that, what about chemistry?
In chemistry, no. I asked my ma'am yesterday, my teacher.
Uh-huh.
She's like only life processes coming, and magnetic effect still some page number 229. No, some
229,
page
yes.
number.
Yeah, page number 229, that is what even I have. So magnetism, okay, these two chapters you do. Life process anyway, we have done few of, no, life process we have not. In life process we have done only that transportation part, I guess. No, only one small part we have
Yeah,
done. Okay,
yeah,
some
that
part
respiration.
respiration, yes. So that is there. And then in magnetism or magnetic effect of electric current, how you are doing there?
It's okay. It's good.
Okay.
I was having confusion in functioning of electric motor and generator, but then there are a lot of YouTube videos which explain really well. So like 3D animation kind of, so I understood.
Actually, yeah, those things, if you have the video, that is always a good explanation than the 2D image, basically 2D picture on your book. So it's not like you have to visualize with the 2D image. Basically, you have to think in your mind, okay, this is how it rotates, and then it changes its commutator and split rings and all those things. But if you see with the video, it will be like much more clear. That's right. Okay. So those things are important. See, in one thing in magnetic for is there's no numericals. That is one advantage. But the questions what come from there is, first is your right hand rule given by Maxwell, the first one, right hand thumb rule. Then Fleming's left hand rule is there, Fleming's right hand rule is there, and then after that the
Hmm.
workings of your AC motor, generator. So these are the
Yeah.
only places where the question comes in magnetism. But it's important. If I say after electricity, if something comes most from the physics, it's magnetism. So electricity and
Okay.
magnetism are two major chapters in physics. After that, everything has small appearances in the exam, but these two contains the major part. Okay, did you find
Okay.
any
So
other
how
doubt?
will you teach? No, no, I did not get any down.
Yeah,
If
you
I'll
were
have
saying.
it.
You were
I
saying
was
something.
asking how will you teach RSA?
How will I teach RSA? Same way we did NCRT. So, see, RSA examples are more, I understand. So basically, the teacher's job increases there, and but that's right, because that's okay, because RSA examples are good. It's much better than NCRT examples and NCRT exercise together. Even
Also,
if you
yeah.
solve NCRT examples and exercise, and still when you go to the examples of RSA, you will really find some very good questions. And exercise is
That's why I was
always
telling that first I'll finish RSA, then I'll take the test.
okay. That's fine. So with RSA also we'll follow the same process like what we did with NCRT. We'll start with a chapter, we'll do all the examples in the class, and then you follow with the exercise. Like that only we'll continue. Because more than
Okay,
NCRT,
sir.
I prefer RSA.
Okay, okay. So, can you open page number 252 on RSA as well?
Okay, right now I do not have the book, but you can tell me the question. Or you can
Okay.
show me through. Okay, your video is not on. It's okay.
In a given AP, if pth PTH term is Q
Pth
and
term.
the two, yeah,
Qth term is
and the
P.
Q, huh, then
Uh,
show that the nth term is P plus Q minus N.
P plus Q minus 1. Okay. Okay, I'll show
Minus
you.
N, not minus 1.
Okay, 1 second. Let me switch on the video so that I can write it also. This question has come into both,
Oh,
and not once. It has come like 2 times, I'm sure. Maybe even 3 times it has come. Okay, so the pth term is, okay, so I'll simply write it as AP is given to you as Q and AQ is given to you as P. Okay, what else? The nth term AN is equal to P plus Q.
yes.
Just p plus q. P plus
Minus
q
n.
minus n. Is this the question? Prove that.
It's the nth term.
Yeah, that is an.
Yeah,
Okay.
that's a question.
Okay, fine. So to solve this, what we do is AP is given to me as AP in the sense pth term. A plus p minus 1 into d is given to me as q, and a plus q minus 1 into d
Q
is
minus
given to me as
p.
p. Now, if I add them up, okay, and I'm looking for a plus n minus 1 into d, should come this. Okay, so if I add them up, let's see what do I get. I'll get it as 2a plus p minus 1 plus q minus 1 into d equal to p plus q. Right? Now, if I open it, I'll get 2a minus 2d plus p plus q into d equal to p plus q. 1 second, just give me, I'll just refill it. It's till here, any doubt you just see.
Mm. हाँ 2 minutes wait करो.
Any doubts till here? How I have simplified and all?
No sir.
Okay. So basically it was p plus q minus 2 inside the bracket. So minus 2d I have written separate, and p plus q still I have kept with d itself. Now, okay, yeah. D, if I find out from here, it will become more complicated or less complicated?
So I have 2 more questions after this. If you can explain.
We'll try to do that. Or anyway, if we can't do it today, we can do it in next. Or you can do one thing. You can send me before the class anytime, and then we can do it in the next class also.
Yeah, okay.
There's a way, 1 second, p plus q minus, and I'm looking for. Okay, so I want to find out d here and then substitute in that. That's all is what I'm looking for. But if d is already separate here also, so p plus q minus 2a by this, more complicated, d equal to p plus q minus 2a divided by p plus q minus 2. This is what if I substitute there also, n minus 1 is not going to get cancelled at all. So what I can do, d I cannot substitute because n I have to somehow get the value and substitute there as well. Okay, tell me the next question quickly by the time.
Okay. If the pth, qth, and rth terms of an AP be a, b, c respectively, then show that a into q minus r plus b into r minus p plus c into p minus q is 0.
Okay.
I don't know what this question means.
No, that question is again, it's easy only. It's not very difficult. But here we are. Okay, this question we can still do it because this question has come, and there was a trick. What I was using here was, what was that? Okay, that if it is not giving me this, maybe the subtraction should give me something here. Okay, let's subtract and check once. A plus p minus 1 into d is nothing but q, and a plus q minus 1 into d is nothing but p. If I subtract this, so it will become minus, minus, minus. Okay, yeah, a minus a will get cancelled. I think this will give us the value of d. Because a was coming into picture, I wanted to avoid it, so subtraction will give. Okay, so d, if I take common here, I'll write p minus 1 minus q plus 1. And this side I'll get q minus p. Okay, yeah, that's working. So if you, this is fine, no, I've written p minus 1 minus of q plus 1 because minus of bracket, right? So minus 1 plus 1 is gone. D into p minus q equals q minus p. So d, I'll get it as q minus p by p minus q, which is nothing but minus 1. So I got the value of d as minus 1. Is it fine till here?
No, sir, I didn't understand anything.
This was easy. Okay, I'll do it
So
once
can you
again.
explain from the starting?
Okay, sure. Yeah, we were adding, that is what we were doing wrong. It's subtraction which gives you the right direction. Your question was the pth term is equal to q, the qth term is equal to p, and then prove the nth term is one
Basically,
of
it
the,
means that one term is Q and the next term is, and the other term is P.
yes. So nth
So what's
term
the
is
third
p
term?
plus q plus n, right?
Yeah.
Okay. So this was the question. No, not pth term
No, P plus Q minus N.
minus n. Okay. Minus n. Fine. So pth term is nothing but a plus p minus 1. It's nothing but a plus p minus 1 into d, right?
Yes, yes.
So a plus p minus 1 into d is given to me as q. So if this only, if I separately write, what will I write? I'll write it as a plus pd minus d equals q. Okay, just open the bracket, that's it.
Yeah, okay.
Same thing, the qth term is p, that means a plus q minus 1 into d equals p. And same, if I open the bracket, I'll write it as a plus qd minus d equals p. Okay,
Okay.
now just subtract these two. So if you subtract, you'll write minus, minus, plus, minus. A minus a cancelled, minus d plus d cancelled. Pd minus qd. So I can take d common and I can write p minus q. Okay. The other side, it will become q minus p. So what will be the value of d? It will become q minus p by p minus q. Can I write it as minus 1 times it will be cancelled
Yes.
out? Okay. Now, if you have reached till here, then with the help of d, we'll find out a by substituting in any reaction. You can substitute in any equation, I mean, still into reaction. Okay. So you can substitute in this or this or this or this, your choice. So if I substitute in this only, let's take the first one itself. So a plus p minus 1 into minus 1 equal to q. This was the equation. So this will be a plus p into minus 1. So minus p minus 1 into minus 1 plus 1 equal to q. So a is equal to p plus q minus 1. Is it fine? I just find out
Yes.
a, substituted everything there. Now, when I have my a ready with me, when I have my d ready with me, minus 1, I can substitute into my nth term. An is equal to a plus n minus 1 into d. Now, what was the value of a? P plus q minus 1. So p plus q minus 1 plus
Okay,
n
okay.
minus
You'll
1.
get P plus Q minus N in the ending.
Yeah, so if you solve it, p plus q minus 1 you multiply there, so you'll get minus n plus 1, cancel, cancel, p plus q minus n is your an. This is
Oh,
what
okay.
we looking to prove.
This was easy, just a bit P and Q was confusing.
It was
Okay, sir.
yeah, I only think the first time when I was doing, I just added them. So addition will give me 2a come into the picture and even d will come into picture. But if you do the subtraction, your a and the d terms will get cancelled. Only thing this will come. This will, your main target is to add or subtract, is to find out d. Once I get my d, with the help of that, I'll find out a. Once I have a and d, like a linear equation I did, like x and y. So once I'll have my d and a, I have to just substitute into an, and you will easily get your answer there. Okay, so remaining questions you send me on the WhatsApp. I will definitely discuss them in the next class. Send me anytime, either
I will try
today.
to do as much as possible if I have any doubt.
Sure, but these questions are good. These questions we should always try, because these kind of questions actually comes in the exam, and this I'm sure about it has come twice or thrice in the boards. That is for sure.
Okay.
And it has come for 2 to 3 marks something. Sometimes for 2, sometimes for 3, I guess. But it has come, that is for sure. So remaining questions, whatever you get doubt or whatever questions, okay, you can do like this. You keep solving whichever question you are getting a doubt, click a picture, send it to me, and then we'll discuss all those questions in the next class. Okay.
In the next class. Okay. So I do all the examples and I do alternate questions on the exercises, if that's fine.
I'll prefer, see, right now you still have time, so don't go for alternate. Try to do each and every question, because sometimes what you leave might come. Alternate questions and all is good when you're doing the revision, but when you're doing for the first time, it's always good to go for all the questions.
Okay. Okay.
I know it will take more time, but it's okay. Right now you can give time. Okay.
Okay. Yes, sir. So also, can you give this recording very early, like in the afternoon or evening or something, because I need to review functional groups again.
Sure, I'll do that. But the thing is, it's gonna be a big video, so it won't be possible for me to share through the WhatsApp and all. But I'll do one thing. I'll send you a YouTube link. So from YouTube you can download it. You know how to download from YouTube?
Yeah. Okay.
Okay.
Wait,
How
do you have a channel?
I do not have a channel basically. I have a channel, but I don't use it for anything like putting videos. It's just that I have to send it to you or I have to send it to the other students. So I'll just put it there. They'll download from there, just like just to sending it.
Oh, okay. Okay.
Okay, so that is there. I'll put it on the YouTube. How do you download from YouTube?
Just click on the download button.
Oh, but that will be in the YouTube only. It won't be in a file.
That I don't know. I'll ask my dad. He'll be knowing.
Okay, I'll tell you a very easy method. You use it in your laptop or in your where?
A laptop anywhere. I use laptop.
Okay, in the laptop, if you have www.youtube.com/xyz something and all will be there. Like this, the URL will be there, right?
Yeah.
So what you do is, after this dot and before y, you just put ss. Okay. You type ss and press enter. You'll get a download link. You'll get an option of download. Click on download. You can download. It's so easy. You can try with any other video. Okay,
how is that linked to you?
No, it's not linked to me. It's like any YouTube videos. You open any YouTube. Do you have a laptop right now next to you?
No, not right now. But I have my tab. I can do. You can speak.
Okay. So in the tab, open YouTube. In a tab.
YouTube.
Okay, you have. Okay, 1 second. If it is a tab, it's Android tab. Okay, you do one thing in Chrome. You open Chrome.
Okay.
In Chrome, you open YouTube.
Yes.
Okay, done?
Yes.
Now look at any song, any video you play.
Okay.
Played?
Oh, yeah.
At the URL column, you might be seeing it's written. What is coming in the URL column now? Okay, is the ad is coming or it's coming the video only?
Video only. It's opening in the app.
Oh, it's opening in the app. No, let it open in the Chrome. Because in laptop and all, there is no app, right? It will open in the Chrome itself.
Yeah. No, we have an app in laptop.
For YouTube? Okay. I use it from Chrome itself. Okay, what is the URL you can see there?
No, I can't see anything.
Okay, so you are in the app, but you're still open through the Chrome browser or any browser basically. So you'll see youtube.com/something. That is the whole URL. So what you have to do is just before this y and after this dot, you type ss and press the enter button. You'll get the option to download. And that download, if you do see the difference between what you are saying, no, I'll just click on the download button and this one. This will give you the file. So this file, you can in fact keep it in a pen drive or anything like that. That is there. The one which you do, clicking on the download button, that is only on your profile and only on that particular system. Like for example, in your tab, if you have clicked on that download option, which is normally below the video like this, right?
Yeah.
So if you click on it, it will be in your tab, in your YouTube channel only. You can't share it to anyone. And even if you open YouTube in your laptop, you can't access the file which you have downloaded. That's the difference. So that will be a file. It's in basically it's in the YouTube database along with your ID, along with that particular. It uses the storage of your device, but it is linked with your ID. So you can't just transfer.
Sir, but if I open this SS thing, how will I find what you are putting?
No.
I mean,
that's not me. I'm telling you, that's not about my video. It's about, see, any video you put SS, it will take you to download that particular video. Now imagine my link. I'll share you that. Okay, my link is say youtube.com/ Pritesh XYZ. Anything comes here. When you put before YSS, if you put and click, it will take you to download that particular video.
okay.
So any video you can download using this. It's very
That
easy.
was very, very informative, sir. Thank you.
Okay, fine. Okay, then it's time. I should leave. So keep solving RSA and send me the doubts, and we'll discuss in the next class. Okay.
Okay, sir. Yes, sir.
See you then.
Okay. Thank you, sir.
Thank you. Stay safe. Take care.
Same to you, sir.